All right, so today we're going to talk about parts of the atom and isotopes. This is probably a review for a lot of you, but I also like to hit it just in case, okay? So when you look at an atom, we have three basic parts. Now, I know some of you guys are really interested in this, and you're going to tell me that really the only elemental particle there, is that can't be broken up into smaller pieces is the electron, and that's true. But for what we're studying in AP Chem, these are like the protons and the neutrons. These are what we're dealing with, and we're not going to try to break the proton and the neutron up. We're not there yet. But protons and neutrons exist in the nucleus. A proton is positive, a neutron is neutral. That's one mistake that a lot of people make. They think that the positive and negative are here, and then they have extra negative on the electrons. Don't get it, okay? So, proton positive, neutron neutral, electron negative. Electron lives in the electron cloud, which orbits, but don't think about it as orbit. It's just a region around the nucleus, and these little electrons, they're so tiny. They're very, very small. So small they're essentially massless, but they do have that negative charge. They're just sort of zipping around, attracted to the positive charge here, which we'll talk about later on. Now, when you think of something like beryllium, beryllium has an atomic number of 4. So what we can say about beryllium is that beryllium has 4 protons, and a neutral atom of beryllium where everything's going to be neutral until we start talking about how they gain and lose electrons and stuff like that. A neutral atom of beryllium has 4 protons and 4 electrons. So at this point in our studies, we're always going to assume that if we have the atomic number, we're just going to be dealing with neutral atoms. So if you have that many protons, you have to have that many electrons. Okay? So now what can be different and doesn't really affect the beryllium is if there is a different number of neutrons. Now, beryllium has 12 different isotopes. Okay? So you'll notice here I've made this handy dandy little chart of the 3 that really matter, okay? Beryllium 7, beryllium 9, and beryllium 10. And you'll notice that they all have 4 protons and 4 electrons in their neutral form, okay? And that's all we're dealing with right now. Don't start thinking about charging our atoms before we're ready to. We're just dealing with atoms of beryllium, and they all have 4 protons, and if they have 4 protons, they pretty much have to have 4 electrons. But if you look here, 7, that tells me the mass of the nucleus, okay? And so 7 minus the 4 protons leaves me 3 neutrons. Remember, these electrons are massless. They don't figure into the mass of the atom. So 9 minus the 4 protons leaves me 5 neutrons in the nucleus. 10 minus the 4 protons is 6 neutrons in the nucleus. Now, I'm sure some of my Bright Tucker AP Chem students are going to say, well, what if we have more protons? You got a different element, okay? So if you had 6 protons, you wouldn't be dealing with beryllium anymore. All beryllium has to have 4 protons. Now, here, just take a note on this. These are 2 ways that you can denote the mass here. So this would be 2 different ways you might see beryllium 10 written. All right.